Chapter 1: Plants and their food. Introduction. Plants are also living beings, so they need food to grow and carry different life processes. They can make their own food from basic substances found in the soil and air with the help of solar energy. Animals cannot make their own food. They eat plants or other plant-eating animals. Nutrition. Substances that provide nourishment are called nutrients, and the process by which the organism obtains its food and utilizes it is called nutrition. There are two types of nutrition: autotrophic and heterotrophic. Autotrophic nutrition in plants. The organisms that can synthesize their food on their own are called autotrophs, and this type of nutrition is called autotrophic nutrition. Green plants are autotrophs. They prepare food by photosynthesis. They release oxygen as a byproduct. Carbon dioxide plus water with sunlight and photosynthesis gives glucose plus oxygen. Did you know? In some plants, photosynthesis also occurs in their green stem. The food-making process in plants takes place mainly in leaves. Therefore, leaves are also called the food factories of plants. Photosynthesis is a complex set of chemical reactions that take place in the plant cells. During the photosynthesis, light energy is converted into chemical energy. In this process, water and carbon dioxide combine to form glucose, and oxygen is released as a byproduct. The following equation summarizes the process of photosynthesis. Carbon dioxide plus water with sunlight and chlorophyll gives glucose plus oxygen. Glucose plus oxygen gives carbon dioxide plus water plus energy. Leaves. Chlorophyll of the leaves traps sunlight and uses it to make food for the plants. Leaves take in carbon dioxide, CO2, from the air through stomata surrounded by guard cells. Food prepared by the leaves is transported to all the parts of the plants by a network of tubes called phloem. With phloem, another tube called xylem occurs through which water from the roots of the plants is brought up to the leaves. Plants also use their prepared food to obtain energy. Importance of photosynthesis. Photosynthesis is the only process through which solar energy is converted into chemical energy as food. Oxygen is released during this process, so all living beings, directly or indirectly, are dependent on the plants for food and oxygen. Did you know? The oxygen released during the photosynthesis is produced during the splitting of water molecules in the plant during the process. Synthesis of plant food other than carbohydrates. Plants also need proteins besides carbohydrates. Plants need nitrogenous substance for proteins. Rhizobium bacteria present in the roots of plants like gram, pea, mung, etc. take up nitrogen from the air and convert it into water-soluble nitrogenous substances. Plant nutrients get replenished in the soil. When animals and plants die, they are decomposed by microorganisms. The nutrients present in the dead body get mixed with the soil, making the soil fertile. Farmers grow a bean crop after a maize or wheat crop, which increases the fertility of the soil. Chemical fertilizers also enrich the soil with nutrients. Did you know? Blue and red light are the best for photosynthesis. From sunlight, which has 7 different colors. Violet, blue, and red light are the most absorbed light by green plants. Heterotrophic nutrition in plants. The organisms which depend on plants for food directly or indirectly are called heterotrophs, like non-green plants and humans. This mode of nutrition is called heterotrophic nutrition. Parasitic mode of nutrition. Some plants depend on other plants called host plant for food and water. Parasitic plants have special roots that penetrate the host plant and absorb nutrients. Some parasites living on the body of the host are called ectoparasites, and those living inside the body of the host are called endoparasites. Cascuta or dodder plant is a plant parasite. It is a total parasite. Mistletoe is not a total parasite. It makes some of its food but depends on the host plant for water and certain nutrients. Did you know parasitic fungi attack several crops, cultivated plants, ornamental and wild plants, often causing serious diseases in them? Rust and smuts are common examples. They are known as plant pathogens. Saprophytic mode of nutrition. Living organisms like fungi that obtain nutrients from dead or decaying matter are called saprophytes. Saprophytes secrete digestive juices on the host's body, breaking organic material into simpler substances in solution. The saprophytes absorb this solution and obtain nutrition from it. Fungi also release some nutrients into the soil. Symbiotic mode of nutrition. It is a special type of partnership among two different types of plants that live together for their sustenance. This partnership is called symbiosis, which means living together, as in lichen. A lichen is actually composed of 2 or 3 distinct organisms. One is fungus, other is algae, and sometimes it also has a photosynthesizing bacterium. The algae contains chlorophyll, prepares the food which is also used by the fungus, and in turn, fungus protects the algae. So, both the plants are benefited by this partnership. Lichens grow in rainy season with the warm atmosphere. Some examples of symbiotic relationship between animals. Number 1. The egret bird eats ticks and mites from the buffalo's skin to get nourishment and in turn helps the buffalo to get rid of parasites. Number 2. The E. coli bacteria live in large intestine of human beings. They get nourishment from the body and help in synthesizing vitamin K. Insectivorous or carnivorous plants. Some plants prepare food by photosynthesis, but they trap insect also to obtain nitrogen from the insects after digesting them. These are called insectivorous plants. Venus flytrap and pitcher plant are insectivorous or carnivorous plants. Difference between parasitic nutrition and saprophytic nutrition. Parasitic nutrition. Number 1. The process of getting food from the other living organism is called parasitic nutrition. Saprophytic nutrition. Number 1. The process of getting food from dead and decaying matter is called saprophytic nutrition. Parasitic nutrition. Number 2. They absorb food from the living organisms. Example, Cascuta. Saprophytic nutrition. Number 2. They absorb the digested food material from the decaying waste. Example, bacteria, fungi. Chapter 2. Animals and their food. Introduction. All living organisms need food to grow and to carry out the various life processes. Green plants can prepare their own food, but humans and animals have to collect variety of food and nutrients. Use of nutrients for harvesting energy, building body substances for growth, and development and providing protection from diseases is called nutrition. Nutrition is obtained in two ways: autotrophic in green plants and heterotrophic in animals. Food habits of animals. Depending on food habits, animals can be categorized as A. Herbivorous, plant-eating animals such as cattle, goat, rabbit, etc. Cattle are also called ruminants. B. Carnivorous, meat-eating animals such as lion, tiger, etc. C. Omnivorous, animals eating both plants and animals such as man, crow, etc. Different ways of taking food. Different animals eat different kinds of food. Bees, butterflies, and hummingbirds suck nectar from flowers, snakes swallow their food, and birds eat with their beaks. Cattle bite and chew the food. Whales, flamingos strain the food from the water. Such animals are called filter feeders. Nutrition in animals. The nutrition of most animals is holozoic, that is, they intake solid form of food. Holozoic nutrition involves 5 steps. Number 1. Ingestion of food. 2. Digestion of food. 3. Absorption of digested food. 4. Utilization or assimilation of food. 5. Ejection of food. Ingestion of food. The process of intake of food by animals is called ingestion. Digestion of food. A chemical process which breaks food into simpler substances with the help of enzymes is called digestion. Enzymes are made up of proteins. They are secreted by the cells of stomach, intestine, and salivary glands. Absorption of digested food. Breaking of food into simpler substances is called digestion. Digested food is absorbed by small intestine. Assimilation or utilization of food. The utilization of digested absorbed food is called assimilation. Ejection of food. The elimination of undigested waste food in the form of feces is called ejection. Nutrition in amoeba, hydra, frog, paramecium, spider, and mosquito. An amoeba is a unicellular organism. With its pseudopodia, it engulfs food particles, forming a vacuole. Here, food is digested. Food is absorbed and assimilated there. Hydra, with its tentacles, ingests food and pushes into the body cavity. Digestive juices digest the food there. Cavity walls absorb the digested food and, in the cells, it is assimilated. The frog uses its tongue to catch insects. Food is digested with its well-developed digestive system. The unicellular paramecium ingests food with cilia, hair-like structure. Digestion is same as that of amoeba. A spider catches insects in its web. It then injects digestive juices into the body of the insect, which digest the body parts of the insect and form a juice. Then, the spider sucks up the juice. The mosquito sucks up the blood of animals with the proboscis. Teeth of different animals. The type and number of teeth in an animal depends upon the type of food it eats. Some animals, as goat, has one type of teeth. One type of teeth is called homodont. Man has heterodont teeth. Herbivores have special jaws and teeth to cut and grind the food. Carnivores have a strong jaw for capturing the prey. With their teeth, they bite, tear, and slice the flesh. In humans, teeth help in chewing and grinding the food to make it digestible. Did you know? At the time of birth, an infant has no teeth. After 6 months or so, milk teeth appear at the center of the lower jaw. Teeth of human beings. An adult human can have a maximum of 32 teeth. Most people have 8 incisors, 4 canines, 8 premolars and 8 molars. Apart from these, some people have 2 molars in each jaw. These are called wisdom teeth. Teeth grow out of the jaw bones. They are present at birth but cannot be seen. The jaw bones are covered by pink-colored gums. As you grow, your teeth also grow. The part of the tooth that grows and becomes out of the gums is called the crown. Below the crown is the long root of the tooth. The root cannot be seen because it is surrounded by gums. The outermost white part of the tooth is covered with the substance called enamel. A cement-like material holds each tooth firmly to the jawbone. Milk teeth. First set of teeth in a baby are 20 in number. These are replaced by permanent teeth as the child grows. Types of teeth. All our teeth are not of same kind. We have 4 types of teeth. Incisors, cutting teeth. The front 4 teeth on each jaw are flat and have a sharp edge. They are used to bite or cut food into small pieces. Canines, tearing teeth. On both sides of the incisors, on each jaw is a sharp pointed tooth called the canine. Canines are used to tear food. Premolars, grinding teeth. These are broad and flat teeth. They grind food and convert it into fine pieces. There are 2 premolars next to each canine. Molars. The remaining teeth in the jaw are also broad and flat. The last 2 or 3 teeth on both sides of each jaw are the molars. These teeth are also used to crush and grind food. Toothache and gum disease. A yellow sticky substance called plaque is deposited on the teeth if you don't brush teeth regularly. Plaque is rich in sugar, hence it contains bacteria. The bacteria produce acids, which dissolve the calcium in the tooth enamel. Hence, the enamel and dentin are corroded. The acid dissolves the minerals that make our tooth enamel hard. Tiny holes appear on the surface of the enamel, which slowly get bigger until one large hole appears. This is called a cavity. The cavities reduce the distance between the outside of the tooth and the nerve endings. The acids produced by the bacteria irritate the nerve endings and cause toothache. Bacteria present in the plaque is not only the cause of toothache, but they can damage the gum and the fiber holding the tooth in position. Over a long period of time, the tooth may become loose and may even fall out. Brushing teeth regularly to remove bacteria from your teeth can help to prevent tooth decay and also gum diseases. Did you know the third molars are also called wisdom teeth? These are the last molar teeth of each side in both the jaws. So, an adult denture will have 4 wisdom teeth. It is so called because it usually appears when a person is between 18 to 20 years of age. Digestion in humans. Digestion of food is a slow process. Several organs work to digest the food. The process starts from the mouth by mastication and enzyme action. Different processes in digestion. Number 1. Mechanical process. Food is broken to small pieces by teeth. Saliva of mouth mixes with the food and converts starch into sugar. It is called mastication. Number 2. Chemical process of digestion. Various enzymes present in saliva, stomach and intestine help in digestion of food. The mouth, oesophagus, stomach, liver, pancreas, small intestine and large intestine take part in the process of digestion. The mouth. During chewing, saliva containing water, mucus and an enzyme, salivary amylase, ptyalin, mixes with the food. Enzyme converts starch of food into simpler sugar, maltose. The chewed food is then pushed into oesophagus and then into the stomach. Our tongue helps in mixing saliva with food. It helps us in talking and tasting the food. It has taste buds which identify various tastes. The oesophagus or food pipe. The esophagus is a muscular tube connecting the throat to the stomach. When food passes into the oesophagus, the opening of the windpipe is closed. Food is pushed into the stomach by the muscular movement of the oesophagus. The stomach. The stomach is a bag-like organ made up of muscles. The walls of the stomach are lined with a membrane called mucosa. The mucosa secretes mucus, which protects the lining of the stomach. Food is churned and made into a paste. The glands present in the stomach walls secrete gastric juices. Gastric juice contains enzymes and hydrochloric acid. The hydrochloric acid in the stomach destroys bacteria and acidify the food. The gastric juices contain the enzyme pepsin. Pepsin starts the digestion of proteins. The action of the enzymes and hydrochloric acid HCl and the churning changes food into a liquid called chyme. The chyme leaves the stomach and enters the small intestine. The intestine. The intestine is divided into two parts. The part connected to the stomach is a long and narrow-coiled tube called the small intestine. The end part of the intestine is thicker and short. It is called the large intestine. The small intestine. Digestion of food begins in the mouth and ends in the small intestine. The small intestine is made up of three parts: the duodenum, the jejunum, and ileum. It is a long but highly coiled tube where the bile juice from gallbladder and pancreatic juice from pancreas mix with food. As the chyme enters the duodenum, several intestinal juices are released. These juices stimulate the gallbladder and pancreas to release special digestive juices, bile and pancreatic juice. The bile juice helps in the digestion of fats. The pancreatic juice helps in the digestion of carbohydrates and proteins. The carbohydrates are broken down into sugar, the proteins into amino acids, and fats into fatty acids and glycerol. The absorption of these molecules takes place in the small intestine. The absorbed nutrients then pass through the bloodstream to the liver, from where they are transported to all the different parts of the body. Did you know? Excess glucose in the blood of humans is converted into a compound called glycogen. This conversion is regulated by a hormone, insulin. Glycogen is stored in the liver. The large intestine. The end part of the intestine is thicker and short and is called large intestine. After the absorption of nutrients in the small intestine, remaining material passes into the large intestine. Most of the water and minerals present in the undigested food are absorbed here, and the remaining part is thrown out of the body through anus. Different enzymes responsible for digestion. Part of alimentary canal, enzyme, substrate acted upon, action or end product. Mouth, ptyalin, starch, maltose. Stomach, hydrochloric acid, pepsin, rennin. Germs, proteins, milk. Kills the germs, peptones, coagulation of milk. Duodenum or ileum. Bile juice, trypsin, amylase, lipase, intestinal juice, maltose, sucrose, lactose, peptidases. Fats, peptones, carbohydrates, maltose, sucrose, lactose, simple peptides. Emulsification of fats, simple peptides, simple sugars, fatty acids, glycerol, glucose or fructose, amino acids. Did you know? Sometimes when one eats hurriedly or talks or laughs while eating, a food chunk may enter the windpipe instead of the food pipe. It leads to violent coughing, which removes the food chunk from the windpipe. Tips for good digestion. Take balanced diet. Chew each mouthful at least 20 times. Sit with your shoulders back and allow your stomach to start digestive process. Do not drink with your meal. More liquid weakens digestive process. Get enough roughage in your food to get the bowel moving. Digestion in grass-eating animals. Grass-eating animals chew half-digested food and are called ruminants. All ruminants are herbivorous. Grass is rich in cellulose and difficult to digest. Many animals cannot digest cellulose. Then, how do ruminants digest their food? Firstly, it requires more chewing. That is why ruminants have big chewing teeth and powerful jaw muscles. Ruminants have unique stomach divided into 4 compartments: rumen, reticulum, omasum and abomasum. The half-chewed grass first goes into rumen. Bacteria and protozoa there break the cellulose. Then, the food enters reticulum, from where it is sent back to mouth as cud to be chewed. This is called ruminating. Rechewed matter is swallowed again. Now the food passes through first 2 chambers, enter the 3rd chamber, the omasum, where food is broken down to smaller pieces. Excess water is absorbed. Finally, it enters the 4th chamber, the abomasum, which is the true stomach, where enzymes help in digestion. After absorption of useful materials, waste is removed through anus. It is called defecation. The solid waste is called feces. Energy from digested food. The glucose present in the cells is broken down in the presence of oxygen, giving energy, carbon dioxide, and water. This process is called respiration. Glucose, obtained after digestion of food, plus oxygen, obtained by breathing, in body cells gives energy plus carbon dioxide plus water, removed by breathing. Chapter 3: Fiber and Fabric. Introduction. Clothes are one of our basic needs. Clothes protect us from heat, cold, rain, and insects. Man began to make clothes only after the invention of agriculture. Here is a study about cloth fibers and their sources. Fibers, the tiny hair structures that are continuous filaments, are called fibers. Animals, plants, and minerals are their sources. Fibers are used for making clothes, carpet, parachute, etc. Fibers are classified as natural fibers, silk, wool of animals' origin, and cotton, jute, flax, or plant origin are natural fibers. Artificial fibers, man-made fibers like nylon, rayon, and polyester are artificial fibers. Plant fibers. Number 1. Cotton. Cotton plants are cultivated to obtain cotton seeds. Fibers are removed from these seeds. Cotton cloth is the most suitable to the body in all the seasons and climate. Number 2. Linen. This fiber is obtained from flax plant. Flax plant, when matured, is uprooted and allowed to rot in water-filled ditches. Once rooted, it dried in the sun yields the fiber. Number 3. Jute. Jute is produced from patson plant. Stem of this plant are rooted in the water, dried up and then beaten to yield jute. Number 4. Coconut. It is extracted from dry coconut and used to make ropes and carpets. Animal fibers. These include wool or the hair fibers like mohair, cashmere, alpaca, vicuna, angora, camel, and rabbit. Also, there are silk filaments, continuous fiber, produced by cocoon spinning silk moth larvae. Wool. It is the hair growing over the skin of some animals such as sheep, goat, camel, rabbit, etc. These are twisted or arranged in order to make them into long strands. Wool absorbs the evaporate moisture. It is a soft, strong, and resists dirt and tearing. Sheep is reared for wool. Some wool-bearing animals are camel, the alpaca, the angora, the cashmere goats, etc. Cashmere wool. It is the finest wool obtained from the cashmere goats found in Kashmir region. It is also known as pashmina. It is used to knit pashmina shawls. Yak wool. The underhair of yaks found in the Ladakh and Tibet region for wool. Mohair. Mohair is obtained from Angora goats found in Ankara, Turkey. It is used for making garments and home furnishings. Did you know? In the wool industry, the sorters are highly prone to get infected by anthrax bacteria, which causes a dreadful blood disease known as sorter's disease. Angora wool. It is obtained from the Angora rabbit. The soft fiber is used in sweaters and clothes of infants. Camel wool. It is obtained from the undercoat of the camel. It is very soft and fine and used to make fabrics, coats and sweaters. Processing of wool. A. Shearing. The fleece of the sheep along with the thin layer of skin is removed from its body. It is called shearing. This process does not hurt the animal. B. Scouring. Process of washing the fleece properly is known as scouring. C. Sorting. In this process, hairs of different textures are separated. Scouring and drying are done repeatedly to get the wool. D. Carding. In this process, fibers are passed through metal teeth to straighten them and remove dirt. E. Spinning. 3 or 4 strands of wool are spun together to form threads of wool. Did you know? Cashmere wool is a name sometimes wrongly applied to any fine, soft wool. Cashmere is any garment made from the Australian cashmere goat that evolved over decades from its wild goat origins. Australian cashmere wool is very different in appearance and texture from the other wools. Characteristics of wool fiber. Curls of wool fiber are spongy. Wool acts as insulator for the wearer. It returns to its original position after being stretched. Wool can be shaped and tailored. Wool is stirred, flame, wear and tear resistant. Silk. Silk fiber is known to man for hundreds of years. Silkworms produce silk. Silk clothes are very light, soft, shiny and has a high tensile strength with the properties of heat insulation and water absorption. Rearing of silkworms feeding on mulberry leaves is called sericulture. It involves the following steps. A. The eggs of other silkworm moth are incubated until they hatch and become larvae or caterpillars. They feed on mulberry leaves. After some time, they reach to pupa stage and begin to spin their cocoons. B. The cocoons are then boiled to kill the insects inside. The silk fiber is obtained from the cocoons by the process known as reeling. Silk obtained here is raw silk. Uses of silk. It is used for making dress materials, curtains, sofa covers and carpets. Health hazards of silk production. Workers employed in the sericulture industry develop respiratory diseases like asthma and bronchitis. Skin of these workers may get infected due to constant dipping of skin in boiling water during the process of killing the insects. Did you know? A silk yarn is as strong as a comparable steel thread. Artificial fibers. Nylon. It is the first artificial fiber. It is water resistant and easy to wash. Terephthalene. It is another artificial fiber, the polyester fiber. It is mixed with cotton, wool and silk. Did you know? A silkworm spins approximately 1 mile of filament and completely encloses itself in a cocoon in about 2-3 days. Table of properties and use of artificial fiber clothes. Types of cloth. Nylon. Properties: high tensile strength, tough, abrasive and crease resistant. Uses: used for making clothes, ropes, carpets, curtains, brushes, etc. Terephthalene. Highly crease resistant, durable, absorbent of moisture and resistant to attack by pests and mildews. Uses:
used in making wash and wear fabrics, seat belts, etc. It is mostly blended with cotton. Polystyrene.
High tensile strength, tough and crease resistant, has good optical clarity.
Used for making protective clothing, light covers and shades.
Chapter 4: Heat and Temperature. Introduction. During summer, you need something cool and cold, but in winter, you need hot glass of milk or a cup of tea. Hot or cold are relative terms depending on the temperature difference. Temperature is the quantity by which you can compare how hot or cold a body is at a particular time. Heat. It is a form of energy known as thermal energy. It can be converted into other forms of energy. Heat is produced by mechanical work. Burning of a fuel also produces heat. In a steam engine, heat produced by burning coal turns water into steam, which drives the engine. Electric energy in an electric heater is converted into heat and light energy. Unit of heat. The quantity of heat required to raise the temperature of 1 gram of water by 1 degree Celsius is called 1 calorie. The unit calorie is denoted by Cal. Big unit of calories is kilocalorie. 1 kilocalorie is equal to 1000 calories. SI unit of heat is joules. 1 calorie is equal to 4.184 joules. Effects of heat. When an object is heated, many changes take place. One is expansion. Expansion. When we heat a substance, average distance between its molecules increases. It occupies more space, so we say heat causes expansion. Some examples of expansion are: a gap is left between two railway tracks to allow the track to expand in summer. Otherwise, tracks may bend. Electric cables between two poles are given sag. This allows them to contract during winter and expand during summer. If sag is not given, cables may break during winter due to contraction. Transfer of heat. There are 3 ways by which the transfer of heat occurs. These are conduction, convection, and radiation. Conduction. When a metal rod is heated at one end, heat flows through the metal to the other end and increases the temperature of the rod. How does this happen? In a solid, molecules are closed pack. When it is heated, the molecules begin to vibrate faster, give energy nearby molecules. The process continues and heat transfers from the hot end to the cold end. Good and poor conductor of heat. The substances which allow to pass heat energy easily are known as good conductors of heat. Metals are good conductors, whereas wood, glass, plastic, and air are bad conductors, as they do not allow heat energy to pass through easily. Poor conductors are good insulators of heat energy. That's why metal vessels are fitted with heat insulating plastic or wooden handles. Seals and polar bears have thick fur with hollow hairs filled with air. Air is heat insulator and keeps the animals warm. Did you know asbestos sheets are preferred over iron sheets for roofing because asbestos is a bad conductor of heat? Other applications of conductors and insulators. Number 1. Cooling coils at the back of refrigerators are made of copper, which conducts heat away easily. Walls and doors have insulating material between their 2 layers to prevent entering from the surroundings. Number 2. We wear woolen clothes in winter. Woolen fibers contain air which acts as an insulator and does not allow body heat to flow out. Convection. It takes place in liquids and gases. Heat energy is carried away from one part to another by the actual movement of the molecules or the atoms of the medium. When water attains a uniform temperature, the cyclic movement of water during heating is called convection current. Convection current in coastal areas. During daytime, land is hotter than sea, so wind blows from sea to the land, while during night, wind blows from the land to the sea. During the night, land is cooler than the sea. Air blows from the cold region to the hot region. It is due to convection. Other applications of the convection currents. Number 1. When the air above land is heated up, it rises and colder air from the nearby surroundings rushes to take its place. This gives rise to storms. Number 2. In rooms, kitchens, ventilators are provided. They expel hot and lighter air, so cold air enters through the doors and windows. Number 3. Birds fly sometimes using hot currents of air and glide effortlessly. Radiation. The transfer of heat from a hot body to a cold body without the help of any medium is called radiation. Radiation can occur in vacuum. Heat of the sun reaches us by radiation. A hot utensil kept away from the flame cools down as it transfers heat to the surroundings by radiation. The rate at which an object radiates or absorbs heat depends on its temperature and nature of surface. Black and rough surfaces are the best radiators and absorbers, while smooth shining surfaces are poor radiators and absorbers. Vacuum flask. It keeps hot liquids hot or cold liquids cold for a long time. The flask is made up of a double-walled glass vessels with vacuum between the walls. Glass reduces the transfer of heat from inside and outside of the flask. Loss of heat through radiation is prevented by silvering the walls of the flask. Hence, it keeps the temperature of the liquid same for longer periods of time. Applications of heat radiation. Solar cookers and solar water heaters are painted black. They absorb heat. Light-colored buildings stay cooler in summer. Light color reflects most of the heat radiation. Coffee and tea stay hot longer in shining pots. Did you know? Radiators in cars, buses and refrigerators are painted black. Black bodies are better absorbers of heat. Table. Distinction between conduction, convection and radiation. Conduction. Number 1. Heat is transmitted by molecules of the medium. Convection. Number 1. Heat is transmitted by molecules of the medium. Radiation. Number 1. Heat can pass through vacuum. Number 2. Material medium is necessary. Material medium is necessary. Material medium is not necessary. Number 3. Heat passes from molecule to molecule. Number 3. Molecules carrying heat more from one part to another. Radiation does not require the presence of molecules. Number 4. It is a slow process. It is a slow process. It is very quick process. Number 5. It travels in any path. It travels in any path. It travels in straight path. Number 6. Solids, liquids and gases are heated by this process. Liquids and gases are heated by this process. Medium is not heated up by this process. Temperature. The degree of hotness or coldness of an object is called its temperature. Temperature is measured by thermometer. Units of temperatures are Fahrenheit F or Celsius C. Fahrenheit scale. In this scale, freezing point of water is 32 degrees and boiling point of water is 312 degrees. Celsius scale. Here, freezing point of water is 0 degree and boiling point is 100 degrees. Clinical thermometer. It is used to measure body temperature. It is made up of narrow tube of thick glass. On one end, a thin glass bulb filled with mercury is there. Glass bulb walls are kept thin so that energy transfers to the mercury inside easily. There is constriction or kink in the tube near the bulb to ensure that mercury does not contract and flow back into the bulb before the temperature has been read. Its calibration is around the normal body temperature of 37 degrees Celsius at 0.2% markings. However, a thermometer based on Fahrenheit scale is still being used as clinical thermometer. How is clinical thermometer used? Before using, wipe the thermometer with an antiseptic solution. Give a jerk to bring mercury in the bulb. Place the thermometer below the tongue for 2 minutes. In case of a child, place it below the armpit. Read the temperature by holding it horizontally. The normal body temperature is marked at 37 degrees Celsius. How to convert Celsius temperature to Fahrenheit temperature and vice versa? Using relation, C degree divided by 100 is equal to F degree minus 32 divided by 180, or F is equal to 9 C degree divided by 5 plus 32. C is equal to F32 multiplied by 5 divided by 9. Laboratory thermometer. A laboratory thermometer is also made up of glass tube. It has a glass bulb with mercury, which on gaining heat rises in the glass capillary tube. The ordinary laboratory thermometer is marked from 0 degrees Celsius to 100 degrees Celsius. Digital thermometer. Nowadays, these thermometers are also used to measure body temperature. They are more accurate than ordinary thermometer. Chapter 5. Acids, Bases and Salts. Introduction. Have you tasted a juice of lime? It is sour due to presence of a chemical called acid. Similarly, if you taste some soap, it tastes bitter due to the presence of a chemical called base. Acids. Acid have sour taste. Fruits like oranges and lemons are sour in taste due to presence of a weak acid, citric acid. Some acids are very dangerous to handle. Sulfuric acid is one of the strongest acids. Our body makes hydrochloric acid in the stomach to digest the food. Classification of acids. Acids are of 3 types. Number 1. On the basis of origin. A. Mineral acid. Acids prepared from the minerals of the earth. Example, sulfuric acid, H2SO4, nitric acid, HNO3. B. Organic acid. Acid obtained from plants and animals. Number 2. On the basis of the number of H-positive ions produced. A. Strong acids. Acids which dissociate in water to form large number of H-positive ions. Example, HCl, HNO3, H2SO4 are strong acids. B. Weak acids. They do not dissociate completely. They give less number of H-positive ions. Example, acetic acid, CH3COOH, lactic acid, C3H6O3 are weak acids. Number 3. On the basis of strength. A. Concentrate acids. These acids contain very little or no water. B. Dilute acids. These acids contain water. Acids can be strong or weak. A strong acid is highly corrosive. It can damage metal, leather, cloth, bones, and living tissues. Sulfuric and nitric acids are strong acids. Weak acids are less corrosive. Acids found in fruits, curd, and other products are mild acids. Acids are compounds. Table upper right sources of organic acids. Sources of organic acids. Organic acid. Grapes, tamarind. Tartaric acid. Vinegar, oxalic acid, tomato. Acetic acid. Sting of ants, bees. Formic acid, apple, malic acid, lemon, orange, citric acid, milk, lactic acid, soft drinks, carbonic acid, spinach. Oxalic acid. Properties of acids. They have a sour taste and turn blue litmus red. Acids are good conductors of electricity. Acids easily dissolve in water. Acid added with water becomes dilute. Acids are corrosive. They can corrode many materials. Reaction with metals. Dilute acids react with some metals to produce salt and hydrogen gas. Example, Mg plus 2HCl gives MgCl2 plus H2. Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Less reactive metals like copper, silver cannot replace hydrogen from acids. Reaction with carbonates. Dilute acids react with carbonate such as calcium carbonate CaCO3 to form salt and carbon dioxide. CaCO3 calcium carbonate plus 2HCl hydrochloric acid gives CaCl2 calcium carbonate plus H2O water plus CO2 carbon dioxide. Reaction with bases. When an acid reacts with a base, salt and water are produced. The reaction is called neutralization reaction. Heat is also evolved. Acid plus base gives salt plus water plus heat. The product salt is neutral. It is neither acidic nor basic. Salt here does not mean common salt. It refers to the compound produced by any neutralization reaction. Uses of acids. Sulfuric acid used in car batteries, in the manufacture of dyes, drugs, detergents, paints, and in the manufacture of fertilizers. Sulfuric acid. It is used in car batteries, manufacturing dyes, drugs, plastics, etc. Hydrochloric acid. It is used to clean sanitary hardware, dyeing of clothes, cleaning metal surface before galvanization. Nitric acid. In the manufacture of explosives, TNT, dyes, in purification of metals such as gold and silver, also in preparation of ammonium nitrate fertilizers. Acetic acid, carbonic acid, and phosphoric acid. Acetic acid for preparing vinegar, which is a preservative for pickles and jams. Carbonic acid used to prepare soft drinks and soda water. Phosphoric acid used to make phosphate fertilizers. Bases. Bases have a soapy touch and bitter taste. They are used to remove grease and dirt. Bases are also compounds. A base contains oxygen along with hydrogen. General properties of bases. Bases are soapy in touch and bitter in taste. They turn red litmus blue. They perform neutralization reaction with acids. Sodium hydroxide and potassium hydroxide are the commonly used bases. Base soluble in water is called alkali. Reaction with acids. With acids, they perform neutralization reaction giving salt and water. NH4OH, ammonium hydroxide base, HCl, hydrochloric acid gives NH4Cl, ammonium chloride salt plus H2O water. Bases are corrosive, soluble in water, colorless liquids. Bases are odorless, exception ammonia. Table of common bases. Name of the base: sodium oxide. Formula: Na2O. Magnesium oxide, MgO. Copper oxide, CuO. Calcium hydroxide, CaOH2. Potassium hydroxide, KOH. Aluminium hydroxide, AlOH3. Ammonium hydroxide, NH4OH. Lithium hydroxide, LiOH. Zinc hydroxide, ZnOH2. Ferric hydroxide, FeOH3. Chromium hydroxide, CrOH3. Uses of bases: calcium hydroxide, CaOH2, slaked lime. It is used to prepare bleaching powder, to prepare mortar used for plastering and whitewashing. Aluminium hydroxide, AlOH3. It is used in manufacture of fertilizers and nitric acid. It is used to prepare washing soda and synthetic fibers. Sodium hydroxide NaOH and potassium hydroxide KOH. They are used in medicines, in the manufacture of artificial fibers, in preparing paper pulp from wood, and in the manufacture of soap. Magnesium hydroxide. They are used as antacids to relieve acidity in stomach. Salts. When an acid reacts with a base, salt and water are produced. Both neutralize each other. Salt is neither acidic nor basic. Properties of salts. Salts have high melting and boiling points. Most salts are soluble in water, and salt solutions are good conductors of electricity. Formation of salts. A strong acid and a strong base react to form a neutral salt. A weak acid and a strong base react to form a basic salt. A strong acid and a weak base react to form a acidic salt. Uses of salts. Number 1. Sodium chloride is used in food, pickles, in the manufacturing of washing soda. Number 2. Sodium carbonate Na2CO3 is used in washing clothes, in the manufacture of glass. Number 3. Sodium bicarbonate NaHCO3 is used as baking soda, in fire extinguishers and in medicines. Number 4. Silver nitrate is used in developing photographic plates. Number 5. Sodium benzoate is used as preservative. Did you know? Alkalis are very corrosive. A suspension of lime in water, called lime water, is used to whitewash walls. Never mix lime in water with bare hand. The strong alkali can corrode your skin. The sting of wasps contains an alkali and it is quite painful. Did you know? Salt NaCl is vital to your health. Your body needs a certain amount of salt for your nerves and muscles to function properly. However, every time you sweat, you lose some of the vital body salts. Excessive sweating can lead to dehydration and collapse. So, doctors advise people who sweat a lot to make up for the water and salt loss by drinking a lot of water. Table. Name of salt and their uses. Name of salt: ammonium chloride, in soldering in dry cells. Sodium bicarbonate, in baking powder, in manufacture of glass. Sodium chloride, for seasoning and preparing food, essential in life processes. Potassium nitrate, in the manufacture of explosives and fertilizers. Sodium nitrate, in the manufacture of fertilizers, as a source of fertilizers, as a source of nitric acid. Identifying acids and bases. An indicator is used to find out whether a substance is acid or a base. Indicators change color. Turmeric powder is a natural indicator. Litmus as acid-base indicator. Litmus is a dye obtained from lichens. It is used in laboratories to identify acid and a base. Acids turn blue litmus red and bases turn red litmus blue. Chapter 6. Changes in matter. Introduction. Change is a continuous process. Seedlings grow into plants. Wood burns to ashes. Milk sours and fruits ripen. Some changes are very slow and some happen very fast. All the changes above show a change in matter. What is matter? Matter is that occupies space and has weight. Matter can exist as solid, liquid, and gas. Matter is made up of atoms and molecules. The arrangement and interaction of these molecules give a substance its physical and chemical properties. How does matter change? Matter keeps on changing from one state to another. Here are some terms related to change in matter. Heat. Heat is a form of energy contained in a body which depends on its mass, temperature, and its specific heat. Vaporization or evaporation. It is the process of conversion of liquid into vapor. Sublimation. In this process, the substance converts from solid state to gaseous state without going into liquid state. Melting. The process of changing a solid into liquid is called melting. Freezing. The process of changing a liquid into solid is called freezing. Boiling. It is the state for a liquid when maximum vapor pressure of the liquid is equal to the external pressure that the liquid is under. Types of changes. Physical change. When the change is temporary and the substance remains chemically the same, no new substance is formed. These changes are reversible. Example, melting of ice, boiling of milk, glowing of bulb, etc. Chemical change. Chemical change give rise to a different kinds of substances, cooking of food items, ripening of fruits, souring of milk, lightening a matchstick, digestion of food are some examples of chemical change. Rusting of iron. When iron is left exposed to moist air, it chemically reacts with oxygen and water in the air to form a powdery substance iron oxide Fe2O3 known as rust. Fe iron plus O2 oxygen plus H2O water gives Fe2O3 iron oxide or rust. Rusting, if not prevented, weakens iron structures and hence may cause heavy losses. Prevention of rusting. Rusting can be prevented by not allowing the iron to come in contact with moisture and air. For this, iron may be painted or galvanized. Some articles are made for stainless steel which do not rust. Steel is made up of chromium, manganese, magnesium, and iron by the process called alloying. Evidences of a chemical reaction. Production of gas. Vinegar and baking soda react to form carbon dioxide gas. CH3COOH vinegar plus NaHCO3 baking soda gives CH3COONA sodium acetate plus CO2 carbon dioxide plus H2O water. Formation of a precipitate. Two chemicals react to form an insoluble substance which settles down as precipitate. CuSO4 copper sulfate plus H2S hydrogen sulfide gives CuS copper sulfide precipitate plus H2SO4 sulfuric acid. Change in color. Potassium permanganate, when reacts with hydrogen peroxide, becomes almost colorless in the solution. Change in energy. During almost all reactions, energy in the form of heat is usually absorbed or released. Release of heat. Reaction accompanied with release of heat are called exothermic reactions. Example, C carbon plus O2 oxygen gives CO2 carbon dioxide plus heat. Heat produced. Absorption of heat. Reaction accompanied with absorption of heat, for example, in the explosion of a firecracker. C carbon plus 2S sulfur gives CS2 carbon disulfide plus heat. Heat absorbed. In some reactions, light and sound also evolved with heat. For example, in the explosion of a firecracker. Change of state. In some chemical reactions, there is a change in physical state of reactants and the products. To show the change of state, S for solid, L for liquid, G for gas, and AQ for aqueous are written after the symbols. Example, formation of water by hydrogen and oxygen. 2Hg hydrogen plus O2G oxygen gives 2H2O water L plus heat absorbed. Types of chemical reactions. Reactions are grouped according to certain patterns. By this, one can predict the products formed in large number of reactions. Some important types are combination reaction. When a compound is formed from simpler substances, the reaction is called combination reaction. Example, burning magnesium in the air. 2 Mg magnesium plus O2 oxygen gives 2 MgO. Decomposition reaction. In this reaction, a compound breaks up into two or more substances. When electricity is passed through water, it breaks up into hydrogen and oxygen. 2H2O water gives 2H2 hydrogen plus O2 oxygen. Single displacement reaction. In this reaction, one element replaces another element from a compound. If an iron piece is suspended in copper sulfate solution, copper gets up deposit on the iron piece. CuSO4 copper sulfate plus Fe iron gives FeSO4 iron sulfate plus Cu copper. Double displacement reactions. In this type of reaction, two compounds react by exchanging their radicals. These are of two types. Precipitation reactions. Two compounds react in their aqueous state to form an insoluble product as a precipitate. Hydrochloric acid react with potassium hydroxide to form potassium chloride, salt and water. HCl hydrochloric acid plus KOH potassium hydroxide gives KCl potassium chloride plus H2O water. Oxidation and reduction reactions. Oxidation is a chemical change in which oxygen is added or hydrogen is removed. Carbon dioxide when carbon is burned in the air. C carbon plus O2 oxygen gives CO2 carbon dioxide. Also, when hydrogen sulfide reacts with chlorine, hydrogen sulfide is said to be oxidized to sulfur by loss of hydrogen. H2S hydrogen sulfide plus Cl2 chlorine gives S sulfur plus 2HCl. Hydrochloric acid. An oxidizing agent provides oxygen or removes from other substance. In the above quoted reaction, oxygen and chlorine are oxidizing agents. Reduction. Reduction involves addition of hydrogen or oxygen. Examples, H2 plus CuO gives Cu plus H2O. Here copper oxide is reduced to copper by removal of oxygen. Cl2 plus H2 gives 2HCl. Here, chloride is said to be reduced to hydrogen chloride by gain of hydrogen. Separating a solid from a solution. By evaporation, a solid dissolved in water can be separated by evaporating the water. Solid will remain as residue. Salt from the seawater is obtained by this method. Crystallization. If you see the grains of sugar under a microscope, you will see that these grains have same basic shape of a cube. These cubic structures are called crystals. Crystals of common substances in water can be obtained by a process called crystallization. Chapter 7. Weather, Climate Change and Adaptations. Introduction. Sometimes air flights are cancelled or various sport matches are postponed due to bad weather. You know it, sometimes you experience fast winds blowing. Weather. It is change in the atmosphere. It may be pleasant in the morning, very hot at noon, rainy in the evening, and maybe cool at night during same day. Elements of weather. Temperature. The maximum temperature at a given place occurs normally in the afternoon and the minimum in the morning. These temperatures are measured by special thermometers. Humidity and rainfall. Humidity is measured by hygrometer. More humidity, more chances of rain. Rain is mainly brought by southwest monsoon, June to September, and northeast monsoon, November to March. Rain is measured by rain gauge. Winds. During winters, wind blow from the mountains of North India towards northern plains. The plains become very cold. During summer, the winds blow from the hot desert of Rajasthan towards Delhi, and Delhi becomes very hot. Predicting the weather. Scientists who study weather are called meteorologists. They can predict weather by studying several patterns and factors that affect weather. Prediction of weather is a complex phenomena and sometimes go wrong. Climate. Climate is the average long-term weather condition of an area. Climate of an area is determined by the distance from the equator, height above sea level, winds, and amounts of moisture, humidity in air. The average climate of Srinagar is cold and dry. Of Delhi is too hot some months and too cold in others. Chennai experiences hot, humid climate for most of the year. Climate zones. The Earth can be divided into three major climatic zones: tropical, temperate, and polar. The average temperature in tropical zone daily is above 18 degrees centigrades, in temperate zone between -3 degrees Celsius and 18 degrees Celsius, while in polar regions, temperature never rise above 10 degrees Celsius. Seasons. The Earth orbits around the Sun somewhat tilted on its axis. Due to this tilt, the hemisphere closer to the Sun has hot weather, while the other at the same time experiences cold weather. The cycle of change in the weather conditions during a year is called seasons. Near the equator of the Earth, air is warm throughout the year. Close to the tropics, the regions have distinct dry and wet seasons. At the poles, the temperatures are always very low. Did you know? During the summer, the temperature of Delhi may be as high as 44 degrees Celsius. One can get a sunstroke at these temperatures if precautions. Adaptations of animals to different climates. Adaptation is the way that enables an animal to live a particular place. It may be a physical adaptation, such as in the size or shape of the animal's body. Each adaptation has been produced by evolution. Adaptation to cold climates. In the polar regions, temperature may drop as -37 degrees Celsius. Animals such as polar bears, penguins, etc. are adapted to it. Let us see how. Polar bears. The bodies of polar bears and several other animals have dense, fine fur that traps air, which is an insulator, keep them warm. Penguins. They also live in polar regions. Their white color helps them to camouflage. They huddle together in the cold that keeps them warm. Penguins, etc. are adapted to it. Seals. Seals have a thick deposition of fat called blubber that protects them from the cold. Ways of reducing heat loss by some animals. Reptiles keep their body warm by absorbing solar radiation during the day. Animals in cold regions have small ears, tails, and short legs. Some mammals hibernate during winter to reduce loss of heat. Adaptation to hot climates, deserts. To escape excessive heat, some animals enter the state of inactivity called aestivation. Different ways by animals keep themselves cool in extreme hot climates are as follows. Animals living in hot climates spend their daylight time in shady places such as burrows. They come out at night. They are called nocturnal animals. They have large ears with blood vessels. The air blowing across the ears cools the blood, which in turn cools the body. A camel has a hump where fat is stored. It provides it food in times of shortage. It can drink large quantity of water at a time. It sweats and urinates very little. Its feet are suitable for walking on soft sand. Adaptation to hot and wet climates. Tropical rainforests. The tropical regions are located near the equator and have hot and wet climate. The tropical rainforest support a large variety of animals because of the warm climate, availability of water, and plenty of food. But there is a tough competition for food and shelter. Animals, therefore, have developed special features to live there. Many animals in rainforests are adapted to live on trees. Trees give them shelter and food. Monkeys and lion-tailed macaque are good climbers. Some animals have a skin color that matches with the surroundings. The jaguar has a spotted skin. It merges well with the shadows of the rainforest floor, making it difficult to be seen. The elephant has a strong sense of smell. It uses its trunk to eat fruits and leaves. It uses its large ears to hear even soft sounds and to keep it cool. Effects of seasonal variation in climate on animals. Animals have to adapt to seasonal changes in order to survive. Change in colors. The Arctic hare changes its coat to camouflage. This enables the animals to escape predators. Migration. Migration is the movement of animals at certain times of year or during a phase of their life cycle. They move in huge numbers for food and water. Birds, butterflies, turtles, salmons are some migratory animals. Birds like the Arctic tern or Arctic region fly away to warmer regions. When the Arctic region has winter, Antarctica has summer. The Arctic tern flies to Antarctica and returns back when it is summer in Arctic. Hibernation. Some animals hibernate throughout the winter. During hibernation, the heartbeat slows down, body temperature lowers, and the animal does not move. It conserves energy. It may last for several days or weeks. Bears, skunks, and some bats hibernate. Climatic change. The climate of a region changes gradually over a very long period of time. According to climate, living organisms also adapt to the changes to survive. Effects of climate change. If climate change occurs over a short period of time, all forms of life will be severely affected. The average temperature of Earth has increased. This will melt ice in polar regions, sea level will increase, and coastal areas will be flooded. In some areas, rainfall will increase and in some it will decrease. It is a prediction, but it is sure that climate change will affect life. Chapter 8. Soil. Introduction. Soil is very important for the sustenance of life on the earth. All living beings, including plants, depend on soil for food. Human beings depend on soil not only for food, but also for clothing and shelter. Let us know more about soil. Soil. The earth has 3 layers. Crust, the uppermost layer, whose uppermost covering is called soil. It provides water and minerals to growing plants. It also provides habitat to many species of organisms like bacteria, fungi, earthworm, snake and rabbit. Without soil, there would be no grass, no crop, no tree and no food for us or for any other animal. The other 2 layers of the earth are mantle and core. Formation of soil. Formation of soil is an ongoing process. During the day, surface of rocks heat up and at night it cools. Due to repeated heating and cooling, rocky surface of earth developed cracks. Cracks widened with time and upper surface of rock began to break into pieces. For millions of years, blowing water crushed rocks into smaller pieces like sand, pebbles and clay. Sand is formed from hard rock, whereas clay is formed from soft rock. As time went by, plants began to grow on land and their remains got mixed with layers of sand, clay, and pebbles. This is soil. The process is still going on. Weathering. The action of natural factor that lead to breaking of rocks into small pieces is known as weathering. Weathering can take place as rainwater gets into crevices in rocks. In cold places, water freezes, expands, and breaks up the rocks into small pieces. Flowing water further breaks them into fine particles. Difference in temperature during the day and night cause cracks in the rocks. Did you know? The mole, a small mammal, can burrow over 100 meters in a day. It is blind and has a big appetite. It eats a lot of soil pests and so is useful to farmers. Unfortunately, it also eats earthworms. Soil as a habitat. Different microorganisms such as bacteria, fungi, algae and protozoa live in the soil. Besides microorganisms, soil beetles, soil mites, earthworms, millipedes, ants, etc. all live in the soil. They break down the remains of plants and animals into simple substances, making the soil fertile. Soil constituents. 4 different types of particles are found in topsoil along with humus. Clay particles. These are very fine particles, smooth to touch. Their diameter is less than 0.005 mm. Number 2. Silt particles. These particles vary from 0.005 to 0.5 mm. They are rough to touch. Number 3. Sand particles. Their size is above 0.5 mm. They are coarse to touch. Number 4. Gravel. They are small rock particles of size more than 2 mm. They have sharp edges, are not transparent and appear black. The decomposed remains of living things form humus, which makes the soil fertile. Minerals are also present in the soil. Properties of soil. Water holding capacity. Water is collected on the land during rainy season. Some part of it evaporates and some part percolates into the soil is retained by it. The ability of soil to retain water is known as its water holding capacity. It depends on the type of soil. Soil also holds air. The space between soil particles is filled with air, which is used by soil organisms to respire. Plant roots also use this air. Did you know? Roots take in air for respiration. That is why the soil near the roots need to be loosened for proper respiration to take place. Earthworms and other burrowing animals help in loosening the soil. Soil profile. Soil stretches up to several feet below the ground level. It is made up of number of layers which vary in thickness from place to place. Each distinct layer is called a horizon. Main horizons of the soil. Horizon A. It is the uppermost layer of soil called topsoil. It consists of sand and small pebbles with humus and clay. It can hold a good amount of water and supports a variety of plants. Horizon B. Below horizon A is horizon B. This is harder than the upper layer. Roots of trees and shrubs are present in this layer. Water-soluble minerals from horizon A reach the accumulation in this region. Horizon C. It is the lowermost layer. It consists of mostly large pieces of rocks. Below horizon C is the hard layer of rock. Types of soil. The soils are grouped into 6 categories. Number 1. Alluvial soil. It is most fertile soil, rich in loam, silt, clay, etc. Cereals, pulses and other crops are cultivated in this soil. Number 2. Black soil. It appears dark due to humus and other salts. Jowar, bajra, cotton, etc. are cultivated in this soil. Number 3. Red soil. It appears red due to high iron contents. Millets, oilseeds, rice, etc. are cultivated in this soil. Number 4. Mountain soil. It is stony and sandy. Fruits, tea, maize, etc. are cultivated in this soil. Number 5. Desert soil. It is rich in sand. Number 6. Laterite soil. This soil is reddish in color. Rice, tea, groundnut, rubber, etc. are cultivated in this soil. Soil is a natural resource. Soil is an important natural resource for sustenance of life on the earth. Soil is the source of all the minerals we use daily. Coal, petroleum, etc. are obtained below the soil in Earth's crust. Soil is the ultimate source of materials for construction purpose. It plays an important role in maintaining water cycle. Plants grow in the top soil. Soil erosion. Soil erosion is the removal of topsoil. This is brought by wind, water or rain. Main causes of soil erosion are: Number 1. Deforestation. Cutting trees to accommodate increasing population. Agriculture, construction of buildings, roads, etc. is deforestation. Roots of trees and plants hold the soil particles firmly. Due to deforestation, soil becomes loose and is easily blown away by winds or flowing water. Number 2. Overgrazing. Overgrazing by large animal population has also destroyed vegetation and resulted in creation of barren lands. Number 3. Poor farming. Poor farming methods have also resulted in soil erosion. Continuous cropping with only one type of crop weakens soil fertility. Forest fires too lead to soil erosion. Soil conservation. Prevention of soil erosion is called soil conservation. Some methods for conserving soil are: Number 1. Afforestation. Planting more and more trees in all the areas possible. Number 2. To reduce wind effect, trees should be planted along with the boundaries of the fields. Number 3. Growing different crops in the field. Number 4. Disposal of inorganic waste and non-biodegradable waste should be prevented into the fields. Number 5. Water and air pollution should be discouraged. Chapter 9. Respiration in Animals and Plants. Introduction. People go for morning walk and do exercise there. In the morning, quality of air is cleaner and richer in oxygen than any other time of the day. So, when a person breathes in fresh air, more oxygen enters into his lungs. Here we will study about respiration in animals and plants. Sustenance of life of an individual needs energy. This comes from the oxidation of food. Thus, respiration is a process of oxidizing food and release of energy in body cells. The main substance oxidized during respiration is glucose. C6H12O6 glucose plus 6O2 oxygen gives 6CO2 carbon dioxide plus 6H2O water plus energy. Did you know? As a baby is born, the breathing movements inflate its lungs. A natural chemical called surfactant helps the alveoli to inflate. All this may be helped by pats on the back and cries of the baby. External respiration. External respiration involves the exchange of gases, that is, oxygen and carbon dioxide and water vapor are given out. Internal respiration involves using the oxygen breathed in to release energy in the cells. Carbon dioxide and water vapor are breathed out. Respiration in human beings. In human, process of respiration involves breathing, gaseous exchange and cellular respiration. Breathing is a continuous process. Air is taken and given out regularly. Breathing consists of two phases: inhalation, taking air in, and exhalation, giving air out. Inhalation. Number 1. Diaphragm contracts and flattens. Exhalation. Diaphragm relaxes and becomes dome-shaped. Number 2. Volume of chest cavity increases. Volume of chest cavity decreases. Lungs expand. Lungs contract. air flows into the lungs, air is forced out of the lungs. Breathing. Number 1. It is only a physical process in which oxygen is taken in and carbon dioxide is given out. Respiration. Number 1. It is a biochemical process in which glucose is oxidized and carbon dioxide and water are released. Number 2. It occurs outside the cells. It occurs inside the cell. Number 3. There is no release of energy. There is a gradual and stepwise release of energy. Number 4. Enzymes are not involved in the process. Enzymes are involved in the process. What makes you breathe? Below your rib cage, there is a sheet of muscles called diaphragm. It contracts and relaxes all the time, and due to this you breathe. What happens to the air that you breathe in? When you breathe, air passes through the nostrils. The hair and mucus present in the nostrils trap dust and germs and warms the air to body temperature. Now it enters the windpipe or trachea. Here, dust and microorganisms are trapped that have managed to pass through the nostrils. The trachea at its lower end is divided into two narrow tubes called bronchi, which further divided into numerous extremely narrow tubes in each lung. These tubes open into tiny air sacs called alveoli. Gaseous exchange in the human body. When you breathe, air fills the alveoli of the lungs, where oxygen from the air passes into the blood in the capillaries and binds to the red blood cells. At the same time, carbon dioxide passes out of the blood into the alveoli. The entire process is known as gaseous exchange. Blood carries oxygen to every cell, where it reacts with glucose to produce energy. Carbon dioxide and water are also produced, which are removed from the body as a waste product. Did you know? On an average a day, a person breathes in and out up to 13,000 liters of air. How is carbon dioxide removed from the body? As the blood flows in the body, it collects carbon dioxide during respiration and carries it to the heart. The heart sends the blood to the lungs and then into air sacs. From there, it is breathed out. Cellular respiration. The body of a living organism gets energy by burning glucose in the cells. It is called respiration. Cellular respiration of two types, aerobic and anaerobic. Aerobic respiration. In this type of cellular respiration, organisms use oxygen to release energy from glucose molecules. Energy released during the process is also used to produce heat. It keeps the body warmer. Energy is accompanied by water and carbon dioxide. The more you work, you need more energy. You breathe faster to supply more oxygen to the body. Did you know? Frogs respire by 3 different ways, using skins called cutaneous respiration, through mouth called buccal respiration, and using lungs known as pulmonary respiration. Anaerobic respiration. When cellular respiration occurs in the absence of oxygen, it is known as anaerobic respiration. At times, when we overexert our muscles fail to receive enough oxygen. They respire and aerobically producing lactic acid, which develops cramps. After taking rest, muscles gain oxygen and begin to respire normally. Lactic acid breaks up and cramps disappear. How do the other organisms breathe? Most of the living beings do aerobic respiration. They have their respiratory system, which is made up of specialized organs. Breathing organs of animals. In unicellular and small multicellular animals, all the cells take up oxygen directly from the air or water and pass out carbon dioxide. Among the advanced animals, there are 3 types of breathing organs: A. Skin, B. Gills, C. Lungs. All these breathing surfaces have the following common features. They have large surface area over which gas exchange can take place rapidly. They are thin so that gases can diffuse rapidly. They have rich blood supply so that more exchange of gases is possible. Animals like earthworm and leech have smooth, thin and moist skin with rich supply of blood. The entire surface of the body helps in exchange of gases. The fish and other aquatic animals like prawn, crab, etc. respires through gills. The insects have branched respiratory tubes or trachea. Tracheal tubes open on the surface of side of body through pores called spiracles. The spiracle allow the gas exchange. Respiration in plants. In plants, the exchange of gases, oxygen and carbon dioxide, also called respiratory gases, takes place through 1. Stomata, 2. lenticels, 3. intercellular space, 4. root hair cells. Exchange of respiratory gases. A. Stomata. Stomata are tiny openings in leaves of plants. When these openings are open, exchange of gases take place and also water vapor escapes out. Stomata have some other parts also which helps it in opening and closing. As a whole, it is called stomata apparatus. B. Lenticels. Woody stem have small openings or sills in the bark called lenticels, which allow oxygen to diffuse into the living stem and carbon dioxide to diffuse out. C. Root hair cells. Root hair cells are delicate cells that remain in contact with air present in cell. The exchange of respiratory gases takes place through them. Exchange of gases in aquatic plants. Water has oxygen and carbon dioxide gases dissolved in it. The aquatic plants absorb the dissolved oxygen gas from the water through their general body structure. Differences between respiration and photosynthesis. The main difference between the two processes are given below. Respiration, number 1. During respiration, products of the digestion such as glucose react with oxygen to form CO2, H2O, and energy is released. Photosynthesis, number 1. During photosynthesis, green plants prepare glucose from CO2 and H2O in the presence of sunlight and chlorophyll. Number 2. During respiration, chemical energy is converted into heat energy. During photosynthesis, light energy is converted into chemical energy. Number 3. During respiration, O2 is observed and CO2 is released. During photosynthesis, CO2 is absorbed and oxygen O2 is given out. Number 4. Respiration takes place inside the body of human or animal in the presence of enzymes. Photosynthesis takes place in green leaves only in the presence of sunlight and chlorophyll. Number 5. Respiration takes place both during day and the night. Photosynthesis takes place only during the daytime. Chapter 10. Transportation of materials in plants and animals. Introduction. Living organisms need various materials to survive. They have to intake them and remove the waste harmful materials. Conducting tissue does this work. In plants, it is xylem and phloem. And in animals, it is circulatory system known as circulation and excretion. In unicellular organisms like amoeba, paramecium, etc., intake of useful substances and removal of waste materials occur across surface. Plants and animals are multicellular. They have a transport system to carry useful substances to every cell of the body and also to remove the waste material produced. Transportation of materials in plants. Plants are classified into 3 categories on the basis of their size or height. Trees. Trees are very big plants with thick stem and deep roots. For example, peepal, neem, coconut, etc. Shrubs. Shrubs are big plants with bushy appearance. For example, rose, mehendi, etc. Herbs. Herbs are small and green plants with delicate stem. For example, grass, crop, plants, etc. Transportation of water and minerals. Transport system in plants is called vascular system, which is made of 2 types of narrow tubes called the xylem and phloem. Water with minerals is absorbed by hair roots and is transported to every part of the plant by xylem tubes, and the tubes that transport food are called phloem. What makes water rise in the xylem tubes? Water rises in the xylem tubes due to number 1. Pressure caused by absorption of water from the soil, and number 2. Evaporation of water from the leaves generate a pull that sucks water right up to the tip of a very tall tree. Transportation of food. Food made by plants through photosynthesis is transported to the stem, branches, flowers, fruits and roots by phloem tubes. Transportation of materials in animals. The unicellular organisms' nutrients reach every part of the cell by diffusion. In multicellular organisms like Hydra, oxygen and nutrients are transported by water and circulated through their bodies. Did you know our body requires about 2 to 3 liters of water every day in order to flush out urea and to keep it under control in our body? Transportation in humans. In humans, transportation is carried by circulatory system. The blood delivers food and oxygen to every cell, and it also carries wastes away. Functions of the circulatory system. Transportation of oxygen O2. It transports O2 from the lungs to each cell for respiration. Transportation of carbon dioxide CO2. The CO2 formed during respiration is breathed out through lungs. Transportation of food. It transports the food absorbed by the intestine to each cell. Transportation of waste. The waste such as urea produced by metabolic activities are carried to kidneys from where they are excreted. Regulation of body temperature. The fluid helps to maintain constant temperature in the body. Clotting. It prevents excessive blood loss by formation of blood clot. Protection. It protects the body against infections. When you do hard work, your heart beats faster to supply more oxygen through the blood for more energy. Human heart. It is the fist-sized muscular organ that pumps oxygen-rich blood throughout the body. It is divided into 4 chambers. Upper 2 chambers are right and left atrium, and lower 2 are left ventricle and right ventricle. Did you know the output of each ventricle per beat is 70 ml? For an athlete, it may be double for this amount. With 72 beats per minute, the ventricle pumps 5 liters of blood per minute. This is called cardiac output. For a normal person in a lifespan of 70 years, our heart pumps 1 million liters of blood. Did you know? The size of the adult human heart is about the size of the fist of that person. Heart pumps blood 70 to 72 times per minute. In 24 hours, it pumps about 7,200 liters of blood. The wall called septum separates the right-hand sides of the heart. Blood circulates to all the parts of body through arteries and veins. Arteries carry oxygenated blood to the body parts while veins carry carbon dioxide-rich blood back to the heart. Did you know? If all the capillaries in an adult body were connected end to end, they would stretch about 96,000 kilometers. Did you know? Aorta, the largest artery in the body, is almost half of the diameter of a garden hose. The capillaries are so thin that it takes 10 of them to equal the thickness of a human hair. Difference between arteries and veins. Arteries, number 1, carry oxygenated blood from the heart to different organs. Veins return deoxygenated blood from the organs to the heart. Number 2, usually deep-seated, superficial in position. Number 3, muscular and thick-walled, less muscular and thin-walled. Number 4, do not contain valves. Number 4, contain valves at regular intervals. Number 5, all arteries conduct oxygenated. All veins conduct deoxygenated. Number 6, blood flows with jerk and is at a high pressure. Blood in veins flows slowly. Did you know? Not all animals have red blood. The color of blood depends upon the type of pigment within the blood that transports oxygen from the lungs to the tissues. Earthworms, leeches and insects have green blood. Starfish and many other invertebrates Animals without a backbone have clear or yellowish blood. How does the heart work? The heart functions as a double pump. Impure blood through veins enters the right atrium. From here, it goes to right ventricle, then transported to the lungs by the pulmonary artery. In lungs, oxygen is replenished and carbon dioxide is taken off. Purified blood reaches left atrium and then to the left ventricle. Left ventricle pumps oxygen-rich blood to all organs of the body through arteries. This process goes on and on and on. The pacemaker of the heart. Some specialized cells in the heart's right atrium produce electrical pulses that cause the heart to beat. This is called heart's natural pacemaker. Sometimes natural pacemakers may be effective, so an artificial small battery-operated device is implanted under the skin of the chest to correct the heartbeat. Composition of blood. The blood of a vertebrate is made up of red blood cells, RBCs, white blood cells, WBCs, and blood platelets. The fluid portion of the blood is called plasma. Red blood cells, RBCs. These cells are red due to hemoglobin. They are responsible for giving oxygen to each tissue and taking carbon dioxide from them. White blood cells, WBCs. They are colorless and smaller in number than RBCs. They defend the body against diseases. Blood platelets. The platelets present in the blood are responsible for clotting of blood and preventing its flow out of the body. Blood transfusion. In case of massive blood loss, blood of another person is given to the patient. It is called blood transfusion. Blood has 4 groups A, B, AB and O. Before transfusion, blood groups should be matched carefully, otherwise, if unmatched groups get mixed, RBCs stick together and it can lead to death. Blood performs 3 different kinds of functions: transportation, protection and regulation. Did you know? Anybody who is healthy, weighs over 50 kgs and is between the age of 18 to 65 years can donate blood. There is about 5 liters of blood in any adult body. A donor may give up to half a liter of blood at one time. This is quickly replaced by the body. Lymphatic system of the human body. When blood flows through the capillaries, some plasma oozes out of its walls. It is collected, filtered and returned to circulatory system by lymph vessels and lymph nodes. Lymph nodes protect the human body from disease-causing organisms and substances. Excretion. Chemical reactions known as metabolism during respiration produce waste products. They are harmful. The excretory organs remove these waste. This process of removing waste is called excretion. Need for excretion in animals. Accumulation of harmful substances in body can cause severe diseases. Therefore, excretion is a very important process. Number 1. Removal of non-nitrogenous wastes. Carbon dioxide and some water vapor is removed by the lungs. Water is removed by urine, sweat and feces. Undigested food material is removed through anus. Number 2. Removal of nitrogenous waste, urea materials. Kidneys in the man excrete nitrogenous wastes. Excretion in animals. In lower animals, waste products are excreted by diffusion through the body surface. Larger animals have special organs for excretion. Human excretory system. A human has 2 kidneys. Kidney contains tiny tubules which act as filters and filter the blood-producing urine. Urine contains urea, ammonia and uric acid. The urine is ultimately drained out of the body. Sweat, a waste material. Sweating takes place during hard work or summer. It contains water, some salts, urea and other materials in small quantity. Evaporation of water of the sweat make you feel cool. Diseases of the kidney. A kidney may fail to work due to infection, disease or injury. If one kidney fails, one can survive with other kidney. But if both kidneys fail, waste products accumulate and life may come in danger. To remove waste material, then dialysis machine is used at regular intervals throughout the life. Did you know the waste products produced in the body by an organism may be harmful or toxic in nature? If they are allowed to accumulate in the body, they can cause serious problems. Therefore, it becomes essential to expel these waste products from the body. Did you know, in just one day, the urinary system cleans your blood over 400 times. Excretion in plants. The waste products of plants include oxygen during photosynthesis and carbon dioxide and water vapors produced during respiration at night. They are removed through stomata present in leaves. Some waste products produced in plants are valuable to mankind. They are resins, gum, natural rubber, and essential oils. Chapter 11. Reproduction in Plants. Introduction. The processes by which new individuals are produced from parents is known as reproduction. It is one of the most important characteristics of the living beings. Two basic objectives of reproduction are continuity of a species and increase in its population. Plants reproduce from buds in their roots, stems, or leaves and form the seeds production in fruits. Modes of reproduction. There are two kinds of reproduction. Sexual reproduction. It is fusion of two cells, gametes, usually coming from two parents. Asexual reproduction. It does not involve the union of gametes. New individual is produced from single parent. Sexual reproduction in plants. Flowering plants produce seeds through a process called sexual reproduction. Non-flowering plants like cedar, pine produce seed in cones. Flower. A flower is the reproductive part of a plant. It develops from the bud, which is usually green and consists of sepals. Sepals protect the part of a flower. Petals are colored or white, seen only when a flower blooms. They attract insects. A stamen is the male reproductive part of the flower. Consists of a long, narrow filament with anther at its tip. Anther produces pollen grains or the male gametes. The pistil is the female part of flower. It consists of stigma and swollen part at bottom is called ovary. Ovary contains ovules which have egg cells, the female gametes of the plant. Unisexual flower. Some plants have separate male and female flowers. The male flower has only the male reproductive parts, namely the stamen. The female flower has only the pistil, which is the female reproductive part. Flowers which contain either the male or female reproductive parts are unisexual. Watermelon, papaya, and chili plants have unisexual flowers. Bisexual flower. Plants like lilies and hibiscus are flowers which have both the male and female parts in the same flower. This means the flower has both stamens and pistil. Such a flower is called a bisexual or a perfect flower. Did you know? Flowers that have both male and female reproductive organs are also known as bisexual hermaphrodites. For example, apple, sweet pea, China rose, rose and brinjal. What is pollination? The transfer of pollen from anther to stigma is called pollination. It may be self-pollination if pollen from a flower reaches the stigma of the same flower, cross-pollination if pollen from a flower reaches the stigma of the other flower. Pollination is done by birds, insects, bats or wind. Fertilization. The process of unification of male gamete with the egg female gamete is called fertilization. The fertilized egg is called zygote. Seed. The fertilized egg cell begins to divide and develop into an embryo, which develops into a seed. The seed coat is the outer covering of the seed. The embryo has a radicle, plumule, and one or two cotyledons. The radicle will develop into the root system with plumule, the shoot system. Cotyledons act as a store of food for the germinating plant. Fruit formation. After fertilization, the ovary begins to grow in size. Its outer walls become thick and form the fruit. When the seeds inside the ovary develop fully, the fruit ripens. Dispersal of seeds. Scattering of seeds over a large area is called dispersal. It helps the seedling to avoid competing with each other, enables the plants to invade new habitats, and helps in the distribution of species. Some methods of dispersals are dispersal by wind. Some seeds have wings, some have hair around them, and some are light in weight. They are easily dispersed by winds. Examples: drumstick, maple, cotton, grass. Dispersal by water. Some seeds are spongy and light, and some have thick fibrous coat. They easily float on water and carried away. Example: lotus, coconut. Dispersal by animals. The spiny and hooked seeds, such as xanthium, get attached to the fur of the animals or our clothes and are carried along. Sometimes animals eat seeds. Undigested seeds are dispersed with the feces. Dispersal by explosion. Fruit of plant like lady's finger, when dried, explodes, spreading seeds away from the mother plant. Vegetative propagation. Some plants reproduce by asexual reproduction or vegetative propagation. Root, stem, leaf, flower of such plants may be propagated into new plants. Examples: banana plant. Vegetative propagation through the roots. Tuberous root of sweet potato, when detached from the parent plant, can grow into a new plant. Some plant roots like mint have buds called adventitious buds. These may grow into new plantlets at some distance away from the parent plant. Vegetative propagation through the stem. Rhizome plants like bamboo, ginger, turmeric propagate from the underground stem. They are called rhizomes. Rhizomes develop buds. The bud grows into a new plant. Tubers. Potato is a modified stem and has buds. When a piece of potato having bud is planted into the soil, it grows into a new potato plant. Runners. Many plants have long thin stems called runners grow horizontally. It takes roots and sprouts new leaves whenever it touches the soil. It gives rise to new plants. Example: grass and strawberry. Bulbs. Bulbs are found in garlic, onion, etc. They are short, thick underground stems which store food. Vegetative propagation through leaves. The leaves of Bryophyllum plants produce buds on their margins. When these are detached and planted in moist soil, buds grow into new plants.
Did you know? Algae reproduce through fragmentation.
Artificial methods of vegetative propagation. These methods are wisely used in agriculture and horticulture. Some methods are cuttings. Plants like rose, bougainvillea can be propagated through cutting from their stem. When cutting buried in the soil, new leaves grow from the nodes. Grafting. In this method, a plant that is strong and resistant to disease is taken as the base plant. It is called the stalk. A stem cutting from another plant graft of a good variety is inserted on the stem of the stalk through a small incision. The graft and the stalk are firmly bound together. In a few weeks, both parts fuse. The stalk provides the root system and the graft provides the stem, flowers, and fruits. Layering. In plants like jasmine and grapevine, the lower branches of the plants are bent down and covered with moist soil after removing a ring of bark from the stem. After a few weeks, new roots develop with the new plants. Tissue culture. A piece of stem, leaf of root tissue is placed under special condition of light and temperature with nutrients and plant hormones in a laboratory. The cells of the tissue divide and give rise to new plants through the tissue culture. Many plants can be regenerated from a single piece of tissue. Chapter 12. Time and motion. Introduction. Time plays an important role in our life. You attend your school at fixed time. If you have to use bus, train, or an airline for your journey, you have to reach the bus stop, railway station, or airport in time. You have to stick to time in your life to keep things running smoothly. Measurement of time. In older days, people used natural events such as rising and setting of sun, phases of moon, and formation of tides for measurement of time, since these events are periodic. Shadows on the changing due to rotation of Earth on its axis. People used this phenomena to guess about time. Sand clocks, water clocks helped to guess the time at night. Burning candle was also used to know time. Sundial. This device is based on the fact that the position and length of the shadow cast by an object changes with the time of the day. A simple sundial has a horizontal circular board with a triangular metal plate fixed vertically on it along north-south direction. The plate casts shadow on the plate at different angles during day. Position of the shadow was utilized to mark the time of the day. Some historical sundials exist in India, Jantar Mantar in New Delhi and Jaipur. How do watches work? The earliest clocks measured time with the help of pendulum. A pendulum has a periodic motion. Its one complete movement is called an oscillation. The time taken to complete one oscillation can be adjusted in desired time intervals, and hence pendulum is used to measure time. How does a quartz watch work? In this watch, a quartz crystal is placed in an electronic circuit with a tiny battery. Small electric current oscillates the crystal with an accurate frequency. The oscillations are translated into pulses. These pulses, with some mechanical parts, drive the watch's hands. How is time noted? Two methods are used for writing 24 in a day. One is 12-hour method, in which time is written as AM, ante-meridian, and PM, post-meridian. From midnight until noon, time period is written as AM, and from noon to midnight, 12-hour period is PM. The another method is the 24-hour. 24 hours mean continuously 1 to 24 hours and is written without any abbreviations. In this method, 17 hours means 5 p.m. in the evening and 00.110 hours means 10 minutes past 12 o'clock at night. Did you know? The hourglass uses the flow of sand to measure time. It consists of two rounded glass bulbs connected by a narrow neck of glass. The upper bulb contains some sand that streams down into bottom bulb, giving the fixed interval of time. Greenwich Mean Time (GMT). It is the local time at Greenwich, London, situated on the prime meridian 0° longitude. It used to calculate time in various parts of the world since 1884. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. 1 day is equal to 24 hours, etc. Unit of time. The standard unit of time is second denoted by S. Bigger unit of time are minute, MIN, hour, H, day, etc. The time taken by the Earth to complete one revolution around the Sun is called a year. Time intervals are measured by stopwatches and stop clocks. Motion. When an object changes its position with time, it is said to be in motion. Motion can be linear, circular, periodic, rotational, oscillatory, or vibratory. Speed. The distance covered by an object in a given interval of time is called speed. It decides whether an object is moving slow or fast. Speed of an object is equal to distance travelled divided by time taken to cover the distance. The SI unit of speed is meter per second or m per s. Calculation distance if speed is known. It can be calculated by the formula distance travelled is equal to speed multiplied by time. Calculation time. It can be calculated by the formula time is equal to distance divided by speed. Uniform and non-uniform motion. When a body travels equal distances in equal intervals of time, it is in uniform motion, and when it does not cover equal distances in equal intervals of time, it is in non-uniform motion. Graphs of motion. If time and distance relationship is represented on a graph, taking time at x-axis and distance at y-axis, you get two types of graph. A. For uniform motion, a straight line. B. For non-uniform motion, not a straight line. Speedometer and odometer. All motor vehicles have a speedometer and an odometer fitted in them. Speedometer measures the speed of a vehicle, while an odometer records the distance travelled by the vehicle. Chapter 13. Electric Current and Circuits. Introduction. The most widely used form of energy is electricity. We cannot imagine a comfortable life without electricity because we use a number of electricity appliances for our comfort and convenience. Here we will study about electricity, electric current and its effects. Electric current. A charge from the higher potential to the lower potential in a battery or a cell. The flow of electric charge per minute time is called the electric current. Electric current is measured by ammeter. The SI unit of current is ampere A. Materials that allow the current to pass through them are known as conductor, and that which do not allow to pass through are called insulators. All metals are good conductors of electricity. All non-metals except graphite are insulators. Electric circuit. It is assumed that the electric current starts from the positive pole of cell of battery. It is then flows through different conducting materials and finally reaches the negative pole. Such a path taken by electric current is called electric circuit. Various devices placed between the positive and negative terminal of cell are called elements of electric circuit. A switch is a part of the circuit which controls the flow of electric current in the circuit. A circuit diagram is drawn using standard symbols. They are connecting cells in series. When a negative terminal of a cell to the positive of the other cell and go on connecting this way other cells. Connecting cells in parallel. When the negative terminals of the cells are connected at one point and all the positive terminals of all cells to another point, cells are called in parallel connection. Heating effect of electric current. Every material resists the flow of electric current through it even if it is good conductor. This is called resistance. Due to this resistance, the wire heats up when electric current is passed through it, called the heating effect of current. Electric appliances like water heater, toaster, ovens, room heaters are based on this principle. Did you know? Iron is called a soft magnetic material because it loses its magnetism easily. Steel is called a hard magnetic material because it does not lose its magnetism so easily. Therefore, iron is used in making electromagnets, whereas steel is used to make permanent magnets. What makes a bulb glow? In an electric bulb, there is a filament of tungsten wire. It has a higher resistance and a very high melting point. When electric current is passed through it, it heats up to 2500 degrees Celsius, hence begin to glow and emit light. Did you know? The common symbol used for an electric fuse is, when the fuse has blown, the first step is to turn off the main switch before looking for the cause of the trouble. How does a fuse work? A fuse is a part of a circuit. It is usually a thin copper wire. It is the weakest point in the circuit. Its thickness is such that when current exceeds a certain value, it melts and breaks off, thus stopping the flow of current. It is a safety device which protects electric appliances from damage. Magnetic effect of electric current. If magnetic compass is placed close to a wire in which electric current is flowing, Compass needle deflects as if some another magnet is attracting it. Metal wire with electric current behaves like a magnet. This property is known as magnetic effect of electric current. Magnetic effect. In 1820, a scientist Oersted concluded that a wire carrying an electric current possesses an area around it where its influence is felt, called the magnetic field. Its strength depends on the strength of the current. How is an electromagnet made? If a wire is wrapped around a piece of iron and electricity is allowed to pass through it, then the iron piece becomes a temporary magnet called an electromagnet. It remains a magnet till electric current keeps flowing. Use of electromagnets. They are used in television, computer, videotapes, electric bells, and telephone. Doctors use small magnets to remove iron dust from a patient's eye. How does an electric bell work? When the switch of an electric doorbell is pressed, electric circuit is completed. Flowing current makes iron rod an electromagnet, which attracts the tiny hammer. Hammer strikes the bell. As the hammer moves towards the bell, circuit is broken and iron loses its magnetism. As the rod loses magnetism, hammer returns to its original position and circuit is completed once again. The above phenomena is again repeated and bell continues to ring as long as switch is kept pressed. Chapter 14. Light. Introduction. As you know, there are certain luminous objects which give out light on their own. These may be natural objects like the sun or man-made objects like the electric bulb and candle. How do we see the objects? Let us study here about some aspects of light. Sources of light. Light is the form of energy which, when falls on the objects, enables us to see them. The sun, electric bulb, and candle are some sources of light. Various sources of light can be grouped as: Number 1. Natural sources of light. The sun, the stars, and insects like glowworm are some natural sources of light. Number 2. Artificial sources of light. Electric bulbs, oil lamps, lanterns, and candle, etc. are some of the man-made or artificial sources of light. Luminous and non-luminous sources. Bodies are visible only by the light they send to our eyes and act as sources of light. They may be either luminous or non-luminous. Luminous sources. The sources of light which give out light of their own are called luminous sources. For example, sun, electric bulb, lamp, etc. Non-luminous sources. Bodies that do not emit light of their own but they reflect the light falling on them and hence become visible are called non-luminous sources. For examples, trees, furniture, house, moon, and planets, etc. Rectilinear propagation of light. Light travels in a straight line. This is called the rectilinear propagation of light. Some examples to prove rectilinear propagation of light. Number 1. Formation of shadows and eclipses. 2. Formation of day and night. 3. When a beam of sunlight enters a dark region through a small hole, we can see the beam of light traveling in straight line. Did you know? The speed of light depends on the nature of the medium. In space or vacuum, the speed of light is 3 lakh kilometers per second, which is the highest speed. In air, it is only marginally less. In water, the speed of light is about 2,25,000 kilometers per second, whereas in glass it is reduced to only about 1,80,000 kilometers per second. Reflection of light. When light bounces back after striking a surface, we say the light has been reflected. This is known as the reflection of light. Most things that we see reflect light. When light falls on the surface, it is reflected unless the surface is black. If it absorbs all light, it appears black. Regular reflection. When a parallel beam of light falls on a smooth surface, like that of a plane mirror, it goes reflected in a definite direction. Such reflection is called a regular reflection. Irregular or diffuse reflection. When a parallel beam of light gets scattered in different directions is called irregular or diffused reflection. What is an image? When you look into a mirror, you see a reflection of yourself. It is called image. An image is formed by a smooth surface of mirror and lenses. The human eyes, the surface of water, produces image. Real and virtual image. The image which can be formed on a screen is real. It is inverted. Formation of image of an object on the retina of our eyes is a real image. Virtual images cannot be formed on a screen. Image formed in a plane mirror is always virtual. It is erect. Mirror and images formed by them. Plane mirror. The images formed by a plane mirror is erect. Virtual. Literally inverted of the same size as the object and appears to be as much behind the mirror as the object is in front of it. Use of plane mirrors. Plane mirrors are commonly used as looking glass, for making periscope and as a reflector in solar cooker. Making a periscope, take a long cardboard box, cut slits at 45-degree angle at both ends, insert plane mirror strip in the slits so that their reflecting surface face each other. Cut a hole opposite the reflecting surface of each mirror. You can see things from the lower hole. Spherical mirror. Portions of a hollow sphere are called spherical mirrors. They are curved. Spherical mirrors are of two types. Concave mirror, spherical mirror whose inner curved surface is the reflective surface. Formation of image by a concave mirror. Uses of a concave mirror. Number 1. In the headlights and searchlights. Number 2. By the dentist to focus light on the tooth. Number 3. It is used as a shaving mirror because image of the face is virtual and magnified. Convex mirror. In this mirror, the outer curved surface is the reflective surface. Formation of an image by a convex mirror. In a convex mirror, image is always virtual, erect and diminished. Here we show the formation of image by a convex mirror for two positions. Uses of convex mirror. As rear view mirror in automobiles to see the traffic coming from behind. Lenses. A lens is a piece of transparent substance having at least one curved surface. Lenses are widely used in spectacles, telescopes and microscope. There are two types of lens. A. Convex lens, a lens having one or two spherical surface such that is thicker at the center than at the edges. It is also called converging lens. B. Concave lens. This lens is thicker at ends than the center. It is also called a diverging lens. The spectrum. Sir Isaac Newton was the first to show that the ordinary white light is made up of 7 colors: violet, indigo, blue, green, yellow, orange, and the red, shortly written as Vibgyor. The pattern of these colors is called a spectrum. When the sun shines through water droplets in the air after it rains, it gets split into 7 colors. It is the rainbow. Soap bubbles and compact disc also displays colors of white light. Chapter 15. Natural disasters. Introduction. There are many natural events that may cause great loss of property and habitat. These events are called natural disasters or calamities. A disaster also causes havoc in ecosystem and results in big economic losses. Earthquakes, floods, hurricanes, cyclones are some such calamities. Atmosphere exerts a lot of pressure upon us, which is counterbalanced by the body pressure inside us. You can feel this pressure by observing the leaves moving or cycling against the direction of the wind. Pressure can be measured. Air pressure. Air exerts pressure at every place known as air or atmospheric pressure. It is not the same at every place. A place at the sea level experiences greater air pressure than a place on a mountain. Air pressure decreases with increasing altitude. Factors on which air pressure depends. Number 1. Altitude. Air pressure decreases with increasing altitude. Example, when you climb a high mountain, your ears pop and your breathing becomes faster. Air pressure outside your body is lower than the blood pressure inside your body. Number 2. Temperature. Atmospheric pressure decreases with increase in temperature and vice versa. Number 3. Water vapor. Moist air is lighter, hence it exerts less pressure. Why does a warm region have low atmospheric pressure? When air becomes warm, it expands and rises up. It expels some amount of air present in the way of rising air. This decreases the amount of air at that particular place. The lesser the amount of air, the lesser is the pressure. Did you know? The winds that blow out of the region of Indian Ocean follow the direction of prevailing trade winds, which is SE direction. As soon as they cross the equator, they are deflected by Coriolis force and they blow as southwest monsoon. What normally causes high atmospheric pressure in a region? When air cools, its molecules come closer, occupying less space. To fill the vacant space, air from surrounding rushes towards it. Now, at this particular place, more air is there. Thus, exerts high atmospheric pressure. Regions where air pressure is relatively high usually experience clear weather, while where air pressure is low experience cloudy, stormy weather. What causes wind? Air moves from areas of high pressure towards areas of low pressure, causing wind. Many winds have names. Most constant winds are trade winds. They blow towards the equator throughout the year. Wind does not move in a straight path. It forms a spiral due to the rotation of the earth. Wind blows from high pressure area to a low pressure area. Did you know? The lift due to moving air also helps birds and aeroplanes to fly. We know that aeroplanes run at a fast speed on the ground before takeoff. This produces fast-moving air or wind above the wings of the plane. This in turn produces a lift that pushes the aeroplane up. In low-pressure areas, air spirals inwards at the Earth's surface and continues to move upwards in a spiral. In high-pressure areas, the air slowly sinks downwards and spreads outwards on reaching the ground. In coastal areas, land heats faster than water during the day. So, air pressure over land becomes less than that of sea. Hence, wind blows from sea towards the land. At night, the land cools faster than water. So, air pressure above land becomes higher than at the surface of the sea. Therefore, at night wind blows from the land towards the sea. Equatorial regions receives maximum amount of heat from the sun. It becomes warm and lighter and rises up. To occupy its space, colder air from polar region rushes there. How are clouds formed? Clouds form when warm humid air moves upward. As it rises, it encounters lower and lower pressure and expands. It cools. As a result, the humid air cools. Water vapor present in air condenses and form tiny droplets or ice crystal and form clouds. When water droplets become large and heavy, they fall downwards in the form of rain or snow. What causes thunderstorms? Thunderstorms are formed where large masses of cold air and warm air meet in a humid region. Cold air being heavier pushes the lighter warm air upwards. As a result, strong upward winds of warm air develop. During condensation, vapors produce heat, thus warming the air in the higher region. The warmer air rises with greater force. This gives rise to a huge storm cloud. Thunderstorms are limited to small areas. A thunderstorm causes sudden heavy rain with lightning and strong winds. Tornadoes may develop from severe thunderstorms. These are violently rotating, very strong winds blowing upwards. Cyclone. Cyclones are large revolving tropical storms caused by winds blowing around a central area of low pressure zone over the ocean. In the southern hemisphere, these storms are called cyclones and rotate in clockwise direction. In the northern hemisphere, they are called hurricanes or typhoons and rotate in an anti-clock direction. How is a cyclone formed? A cyclone always forms in an ocean when a vast surface of water heats up. Heated water in turn heats the air above it. Warm air rises up rapidly and creates a strong upward wind rotating spirally. As the warm moisture reaches a certain height, it cools and condenses into water droplets and form clouds. When vapor condenses, it releases heat. The heat warms the air in the upper regions and makes the air rise further, adding speed to the rotating air column. The large rotating wind storm is called a cyclone. A cyclone can have the wind speed more than 120 kilometers per hour, and it can spread up to a diameter of several thousands kilometers. Regions prone to cyclone. India has a long coastal line of 7,517 kilometers, which makes it vulnerable to cyclones. In our country, cyclones generally strike the east coast, although they affect both the Bay of Bengal and the Arabian Sea. A cyclone alert is issued 48 hours in advance of expected cyclone over coastal areas. A cyclone warning is issued 24 hours in advance. Destruction caused by cyclones. Cyclones cause heavy rain and storm surges. The surge causes a havoc, destroying property and life, uprooting trees and reducing soil fertility. Very strong winds may damage communication systems and disrupt electricity. Cyclone flood pollutes drinking water sources. Chapter 16. Water, a wonderful liquid. Introduction. Water is one of the prime necessities of life. It is a vital body fluid which regulates life process. It is essential for germination of seeds and carries out photosynthesis in plants. It is the lifeline for navigation, agriculture and industry. About 3/4 of Earth's surface is covered with water. This water is mostly stored in the ocean. Water provides habitat to a large number of marine plants and animals. Did you know? The Himalayas are a great water resources with a total snow cover of about 16,000 square kilometers. There are more than 15,000 glaciers providing water to a number of rivers like Brahmaputra and Ganges. Water, a renewable natural resource. Water is a natural resource. Natural resources are of two kinds, renewable and non-renewable. Limited availability of fresh water. Although there is plenty of water on the earth, but only 2% of water on earth is fresh water. Most of it is inaccessible as it is in frozen state in the polar regions. A small amount of fresh water is accessible from stream, ponds, lakes, rivers, and underground sources. Natural resources like water and air, which are constantly renewed through rapid natural cycle, are called renewable natural resources. Forms of water. Water occurs in 3 states: ice, liquid, and gas. At polar regions and at high mountains, it is in solid state ice. In the oceans, seas, river, lakes, etc., it is in the liquid state liquid. In the air, it is in vapor state gas. Did you know? Self-closing taps are reliable water-conserving gadgets installed at public places like malls and multiplexes, call centers, and railway stations. These taps automatically shut off when not in use and avoid wastage of water. Sources of fresh water. Rain. It is the main source of fresh water. Some places receive heavy rains causing flood and others very little or no rain causing drought. Groundwater. It is one of the most valuable sources of fresh water on the earth. Below horizon of Earth's crust, it is a layer of rocks. At some places, it's porous. Below the porous layer, there are huge spaces which are filled by the percolation water into the ground for millions of years. It is groundwater. The level of water under the ground is known as the water level. Aquifer. The rainwater that has collected in the empty space below the porous layer rock is known as aquifer. Factors affecting groundwater. In many areas, groundwater has been nearly exhausted. It is being used at very increasing rate due to increase in human population, industries, and agriculture. Increase in population. Human population is increasing all the time. To meet its requirement for drinking, constructing building need a huge supply of water. As the rainwater collected in dams, lakes and rivers is not enough to fulfill the requirements of people, more and more groundwater is being used. Agriculture. Due to increasing population, more land is being cultivated for food. Mainly the agriculture in our country depends on the rains, but rain is not equally divided to each area in quantity and time span. So far, irrigation of crops, groundwater is being used. Increase in industries. In industries, the manufacture of almost every item that we use requires water. Most industries use groundwater, thus depletion of groundwater sources. How are we obstructing the process that renews groundwater? Through undisturbed, uneven landscape, rainwater percolates into the ground and replenishes groundwater sources. But man is using land for industries, houses, roads and cities, reducing the amount of water percolating into the ground. Deforestation has also affected the groundwater. Distribution of fresh water. In our country, rainfall varies from place to place and the distribution of water is uneven. Some places receive heavy rainfall and some receive very little or no rainfall. Regions with good rainfall have a good amount of groundwater than the other places. Water management. Increasing population has put tremendous pressure on the freshwater sources. An elaborate water supply system costs a very large amount of money. So, we should not waste water and save every drop as it is becoming a scarce thing. Here are some tips to save water. Do not waste water while brushing, bathing and washing clothes. Use a minimum of water for flushing the toilet. Harvest the water. Water pollution. Water safe for human consumption is called potable water. Polluting rivers, lakes and wells are dangerous because they are the primary sources of drinking water. Water can be contaminated due to the following reasons. Improper sewage facilities. Without recycling, most of the sewage water flows into the rivers. Industrial waste. Chemical and industrial waste drain into water. These wastes are very harmful for life. Improper agricultural practices. Excessive use of fertilizers and pesticides. They remain in the soil and washed away into rivers when it rains, polluting water. Religious and social practices. Carcasses of animals are disposed of in rivers. Untreated toxic chemicals of industries, household waste, religious offerings and plastic bags are also thrown into the rivers, polluting the water. Water conservation. Saving water without pollution is its conservation. Rainwater harvesting is a solution to the problem of depletion groundwater. Check dams. Rainwater percolates into the soil only if it does not flow away quickly. If a check dam is constructed preventing flow of water, water will percolate into the ground, raising the level of underground water. Drip irrigation. Drip irrigation system supplies the required amount of water only around the roots. It minimizes the use of water. Farmers can grow high-yielding crops in minimized amount of water, thus saving water. Did you know the Indian subcontinent gets a large amount of rain during a summer monsoon? Tamil Nadu is the only state in our country which gets most of its rain during winter monsoon. Chapter 17. Forests, our lifeline. Introduction. A forest is a biotic community, uncultivated land composed of trees, shrubs, herbs and climbers. They also support a variety of animal life. They are invaluable wealth of a nation and a renewable natural resource. In last 100 years, to cope up the needs of growing population, forests are being cut mercilessly. It is posing serious threat to our economy, quality of life and environment. Forest type in India. There are xerophytic scrub forest in the tropics as in the Western Ghat, Assam, North Bengal and conifers in the temperate regions. In between, there are many intermediate types of forests. Evergreen forests. These forests remain evergreen throughout the year. These are also called rainforests. The trees are tall with huge crowns. They are very dense. Common trees here are mahogany, rosewood, sandalwood. Evergreens are found in Assam, Meghalaya, Mizoram, Andaman and the Western Ghats. Deciduous forests. Here the trees shed their leaves every year in autumn. They grow in hot and wet climate. Common trees here are teak, sal, shisham and sakua. These forests are in the foothills of Himalayas and on the hills of southern plateau. Coniferous forests. The trees bear cones instead of fruits, so called conifers. They have needle-like leaves. They grow in very cold region. Pine, spruce, chir and deodar are conifers. They grow in Kashmir and Himachal Pradesh. Mangrove forests. These grow in marshy areas found in deltas of Ganges and Brahmaputra River in West Bengal. The important tree here is Sundari. Thorny forests. Thorny forests grow in desert areas. Due to scarcity of water, these have thorns and spines instead of leaves to save water. Common plants here are babool, kekar and cactus. They are found in dry regions of Rajasthan, Punjab and Gujarat. Layers in forest. A forest roughly has 3 layers: canopy, undergrowth and forest floor. Canopy. The topmost layer of the forest is called canopy. Form undergrowth. Shrubs, herbs and creepers are also part of the undergrowth. Forest floor. It is ground surface of the forest. It is formed of soil. It contains remains of dead and decaying matter called humus. A forest has many types of plants. They can all be divided into 3 categories. Number 1. Plants with lifespan of 1 year called annuals as herb. 2. Plants with lifespan of 2 years called biennial. 3. Plants that survive for several years called perennials as shrubs and trees. Uses of forest. A forest is a renewable natural resource of edible fruits, oils, fibers, medicines, wood, gum, rubber, etc. Forest, a source of wood. It is a rich source of timber used for constructing houses, making furniture and building ships. Teak, shisham, oak, sal, sandalwood are sources of wood. Bamboo grown in northeastern and southwestern part of India is used as a timber substitute. Forest, a source of medicinal plant and edible fruits. Several herbs and plants that grow in forest are used in medicines. Plants in the forest produce natural gums. Honey is obtained from honeybees. Fruits like mango, custard apple, cashew, orange, coconut, etc. grow wild in the forests. Forests, a storehouse of biodiversity. A forest is a home to many kinds of plants and animals. Different species of plants and animals are found in different forests at different places on earth. Every forest region is a vast storehouse of biodiversity. So, damage to even a part of forest results in loss of several varieties of plants and animals. Forest, air purifiers. The dense growth of plants and trees in a forest absorb huge quantities of carbon dioxide and release oxygen during photosynthesis, thus purifying air. Forests and rainfall. The dense growth of plants in a forest creates favorable conditions for rain. Forests check the flow of rainwater so it percolates into the ground. Forests and soil erosion. The dense growth of plants in the forest reduces the force of wind and flowing water, thereby preventing soil erosion. Interdependence of plants and animals in a forest. The plants and animals in a forest depend on each other for survival. Plants are autotrophs or producers as they produce their own food. All animals are heterotrophs called consumers. Herbivores eat plants and carnivores eat flesh of other animals, herbivores. Omnivores eat both plants and animals. Food chains of a forest. In any forest, there are several food chains. A food chain shows how certain animals living in a region get their food. A food chain links a few herbivores and carnivores. A food chain starts with plants and ends with carnivores. All food chains are powered by food web. Several food chains of a region interlink to form a food web. A food web tells how plants and animals are closely linked. If any member is affected, the entire food web gets disrupted. The interdependence of various living things within a food chain helps in maintaining the balance of plant and animals population in forest. Decomposers, important member of the forest. Decomposers feed on dead plant and animals and convert them into simpler substances which mix into the soil. Fungi, bacteria, dung beetles, termites, and earthworms are some decomposers. They make the soil fertile. Destruction of forests. Forests have come under grave pressure with the increasing human population. Uncontrolled deforestation for various purposes have caused severe damage to forests. Did you know? As a first step towards making the people forest conscious, a nationwide celebration of an annual tree planting festival called One Mahotsava is organized every year on 5th of July. Depletion of wildlife due to deforestation. Deforestation affects the wild animals in the following ways. Number 1. Absence of cover or shelter. The forest vegetation, tall grasses, etc. are used as cover or shelter by wild animals. Once cover is absent, animals will not survive. Number 2. Reduction in area of movement. Deforestation reduces freedom of movement of the wild animals, which are unable to maintain their numbers due to less food available. Number 3. Destruction of wild plants. Human beings have destroyed many wild plants which form the food of the wild animals for getting more timber. The absence of chief food may even result in ultimate depletion and extinction of some wild animals. Number 4. Building roads and railways. Most of the roads and railway route pass through dense forest. This restricts the movement of animals. Number 5. Pollution. The rivers and streams running through forest, if polluted, can act as killing agent. Repeat, drinking polluted water exposes the wild animals to diseases resulting into death. Did you know? The International Union for Conservation of Nature, IUCN, and the World Conservation Monitoring Center, WCMC, maintain a global list of endangered and vulnerable animal species called Conservation of Forests. We must undertake the following steps to conserve forests. Number 1. Large-scale cutting of forest trees must be stopped. 2. Overgrazing by animals should be stopped. 3. The forest resources should be carefully and judicially used. 4. Alternate source of energy instead of wood should be found. Number 5. Above all, more and more trees should be planted. Chapter 18. Wastewater Management. Introduction. Water is our life. It is used for various purposes, for drinking, in household activities, and in industries. Used water is polluted, having urine, feces, detergent, dirt, oil, and various chemicals in it. It is called wastewater. Wastewater, dirty water or wastewater can be classified as domestic wastewater and industrial wastewater. Normally, wastewater are conducted to treatment plants for removing undesirable components, organic or inorganic. If these pollutants discharged directly into the river, it may interfere with the self-cleaning mechanism of water bodies. Microorganisms present in water bodies use organic waste as food and break into simple substances. But if pollutant does not degrade or its quantity is so much that microorganisms are unable to cope with, water remains polluted. Sometimes helpful chemicals present in the wastes destroy microorganisms. What does wastewater contain? Domestic wastewater contains soap, food particles, toothpaste, bits of paper, traces of oil, dust, urine, and human excreta. The wastewater flowing through the drainage pipe is called sewage. How does sewage water harm aquatic life? If sewage water is released into a river, microorganisms like bacteria, fungi, and algae grow in large numbers. These organisms decompose organic waste using oxygen in water. Also, it does not allow sunlight to aquatic plants for photosynthesis. This as a whole affects aquatic life. Lack of sanitation can spread diseases. Many people in our country do not have access to sanitation facilities. They use any space available to defecate. Human excreta left on the land can contaminate water sources, which if used may spread waterborne diseases. Similarly, open drainage systems are health hazards. Mosquitoes breed there. During monsoon, drainage water mixes with river water and pollute it. How to control sewage? Number 1. Use flushes with low capacity. Number 2. Do not throw household used products in the water, like cleansers, medicine, oil paint, etc. They are not removed by water treatment plants. Number 3. Cooking oil, butter, meat, fat, and plastic can clog pipes, so should not be disposed in the water. A city produces millions of liters of wastewater every day. It can be cleaned and reused through sewage treatment plants. How is wastewater treated in a sewage treatment plant? Wastewater is treated using a series of physical and chemical treatment. Removal of large solids from the sewage. The wastewater is made to pass through screens which separate solid such as pieces of stones, wood, plastics, glass and metal. Sedimentation of waste from water. Now, wastewater is filled in large tanks and kept undisturbed for 8 to 12 hours. During this period, insoluble organic waste settles at the bottom of the tank. Settled waste is called sludge. It can be converted into manure or can be used as a landfill. Decomposition of organic matter. After separating the sludge from the sewage, the wastewater is transferred into large tanks where air with microorganisms is bubbled into the tank. Microorganisms decompose the organic matter using oxygen of the air. Final separation of sediments and chemical treatment. In the last, wastewater is sent to sedimentation tank. Here, decomposed waste settles down. Now water is transferred to a tank where chlorine is added to kill the microorganisms present in the water. Now the water is absolutely clean and fit for human use. This water can also be discharged into oceans, rivers and lakes. An alternate arrangement for sewage disposal. A septic tank can be used to treat household sewage. A large concrete tank is built under the ground with inlet and outlet pipes. The inlet pipe carries household sewage to the tank. Bacteria present in the tank decompose a solid waste. The excess water flows out of the tank through the outlet pipe into the soil. Decomposed solid waste must be removed from the tank periodically. With a few modifications, a septic tank can be converted into an efficient biogas plant. Chemical toilets. A chemical toilet uses chemicals to disinfect the waste. It is mostly used in aircraft. A chemical toilet uses solution of chemicals to disinfect and deodorize the waste. Better housekeeping practices. Here are few simple steps to be taken at home which can minimize the strain on the water supply system. Do not dispose of oils and fats in the kitchen sink. They can block your pipes. Do not dispose of used tea leaves, solid food remains, sanitary napkins, etc. in the kitchen sink or in the toilet. They clog drains and present free flow of oxygen. Do not dispose of chemicals such as paints, medicines and insecticides in the sink. They kill microbes that clean the water.